Hi, I'm Dr. K.Nevelsteen. In this demo, I'm going to be showing you how IPSME can be used to form an ecosystem. Translators are added dynamically to the ecosystem, and translations are added to the ecosystem external to the systems being integrated. This demo implements client-side interoperability. Standards in the metaverse are difficult because we're dealing with a system of independent systems. Each system acts independently of others, meaning can be updated without notification. IPSME doesn't avoid standards, but avoids the need for standards. Standards can reduce the complexity of the ecosystem as a whole. All components in this demo are connected to a local messaging environment, namely the native macOS Distributed Notification Center. First, let's do some toy problems. Up here, I have a component that allows me to push messages to my local messaging environment. So any browser allows you to add addresses, put an address in the address bar and open up your default browser. So let's try that. We're going to push a message to our messaging environment. We're going to say https trispace.com, and we'll notice that nothing happens. But our message did get pushed to the local messaging environment. The operating system has the ability to open up a URL in your default browser. There's an API for that. So what we're going to do is we're going to dynamically add a translator into our system that does exactly that. It binds that message to the ability of the operating system to open that URL. So I'm going to start that translator. And now if I try it again, https trispace.com, and now you'll see that my default browser opens up with that URL. So we can go one step further. The operating system can open up any application basically. So what we can do is we can say, I actually want to start Firefox with that link instead. So I'm going to type Firefox and trispace.com. And then we should get the same page in Firefox also. This is similar to basically what you have with deep linking on mobile platforms nowadays. So now I'm going to surf to a page here. And we'll see here is a URL, https trispace.com, and a link, an HTML link like normal. So if you click on it, then we're going to open up a tab with that address again. Nothing new. This is very well known. But here we have something a little bit different. Here it says Firefox/trispace.com. So will that work? So if I click on it, then Firefox indeed opens up. So how does that work? So what I've done is I use broadcast channel from the browser as a messaging environment for the browser. And then I've built a reflector from that messaging environment to the local messaging environment of the operating system. And the browser, what it does is it sends out a message for IPSME publish, and it publishes that URL. Then our translator on the local messaging environment translates that call into an operating system call to open up that URL, and therefore it works. So now we're going to use that technique to build a warp from one website to another website. So instead of sending a URL, we're going to send a more complicated protocol over the messaging environment. So I'm going to open up another site here. And you see that the protocol here is quite a lot more complicated than just sending out the URL. We have the user identity, and then we have the portal we're going to, and then a referrer ID, and the time date when the message was sent. So what I'm going to do is I'm going to send this message out into the local messaging environment. So if I click the teleporter, then the message gets sent out. But again, no one understands this message because of the fact that this is a very new protocol. So what I'm going to do is I'm going to add a translator to the system. I'm going to that understands that protocol, and then it's going to send out a message, a translated message from this protocol to a URL protocol that the HTTP translator can also understand. So now if I click on the message, we'll see that Firefox opens up as normal. You can also see already that the user identity and the hyperport has already been filled in through message passing. We can hardly call that really a warp, because the page loads up wherever it desires, and basically you see the loading of the website. So this is basically you're just opening out of the website. So we want to get a more of a warp effect going. So that means we need to load the destination in the background, and then we need to switch to the destination when the destination is ready to accept the user. So what I'm going to do is, instead of, again, I'm not altering the systems. What I'm going to do is I'm going to add another component to the environment. I'm going to add a user interface manager. Now, the user interface manager is going to help by positioning the windows and then also switching the windows when the systems are ready. So now if I do the teleport again, so now we have a somewhat more believable teleport effect where we have gone from one website to another. And you notice that the source window has disappeared as well. So enough toy problems. Now let's see a legitimate example. I'm going to jump into my virtual world. Loading time is long because of the fact that I have a computer from 2017. And what I'm going to do is I'm going to teleport to another website from within, which is also then a virtual world from this virtual world. And I've landed in crypto voxels. And we see that our source has also been removed. In one of my previous videos, I integrated Minecraft and Doom 3, but I kind of cheated because Minecraft and Doom 3 were both loaded for the teleport. So what I've done is taken my old Doom 3 project and I've updated the code for the newest macOS version, and then I made a translator to translate this new warp protocol to the old Doom 3 API that I had back then. So what I'm going to do now is I'm going to start that translator, and then I should be able to call up Doom just like I do any other web page. So now you can see that Doom 3 is loading in the background. And when ready, we get a message here on the UI component that it is actually ready and I can engage. When I click here, we teleport to Doom 3. Okay, now let's see a full warp. So I'm going to load my virtual world. And so it is the responsibility of the Doom translator to then load Doom in the background, translate the warp messages from this virtual world to the Doom API, and then together with the UI manager manipulate the windows to simulate the warp. So now if I jump on the big portal in the center here, we should get a Doom teleport. And you can see that the source virtual world has been closed properly. So during this entire demo, I've been dynamically adding translators to the ecosystem to add interoperability between existing systems. So other systems can actually join this ecosystem. What they need to do is basically be present on the platform, macOS, and then they have to have an exposed API for the functionality they want to expose. So in this case, a warp would be the case. And then translators can be made from the ecosystem to the API of the systems that's being added to the platform. So IPSME allows for interoperability between all applications, web and native OS. Thank you very much.